Video, we will going to take up the one more problem on cams. The problem reads as a knife edge follower having a lift is of 50 mm, having a base circle is 50 mm, outstroke with simple harmonic motion for a 60-degree cam rotation, dwell for 45-degree cam rotation, return stroke with simple harmonic motion for 90-degree cam rotation, dwell for the remaining period. Construct the cam profile. Assume cam and follower thickness of 15 mm and here the follower is offset by 10 mm to the right of the cam center. So this is the condition which is given to us. So first thing is we need to create the model. Then we need to assemble the model and then we need to give the relationship for the model and finally to show how this actually the cam works by using the Fusion software. So to do that, so first we need to go for the first part, which is the cam housing, or sorry, the housing part or the housing plate. So this is the first part which we're going to create. And to do that, so first I will go for the Fusion software. So here I'll go for hybrid. So first I will go for a sketch, click on the front plane, then come back to this. I will create this particular model. I want the rectangle of 220 by 260 and 60 mm here. So first we will going to create that. So here first is 260. So I will go for rectangle, select some arbitrary point and create a rectangle. Then this dimension is the depth is 260. So dimension, you take this dimension as 260. Then I want to take this dimension which is 220. Then with reference to the center, if you are talking about 160, so from dimension from this to here, I want to make this as 160. Okay. Again, from the right hand side, it is 100. So go to dimension between this and this, you make it 100. Okay. So this is the actual dimension what we want. So this is the actual part of this housing plate. Okay. Once you do that, now I'll go for finish sketch and this thickness is 15 mm. So go to 3D and here go to extrude, give the distance as 15 mm. So once you do that, now we want to create a hole of diameter 25, which is at the same center. Okay. So to do that, I will go for sketch, click on this plane. I will go for circle, select some arbitrary circle and give the dimension as diameter is 25. Then go to coincident, select on this point with reference to this. Okay. So here I'll go for finish sketch and go to extrude, select on this and give the distance as through all and flip it and say cut. So this portion is over. Now we want to create this 60 by 220. So to do that, I will go for sketch, click on the top plane, top surface of the model and go to rectangle, select from here and take the dimension here. Go to dimension for this and you make it 220. And similarly, this dimension is for 60. Okay. Once you do that, now we will have the finish sketch and go to extrude, select this portion and give the distance as minus 15 because this is the depth what we are trying to talk about. And go to join, yes, Once you do that, now we will going to create this square slot. So to do that, I will go for sketch, click on the top surface of the model and go to rectangle, create some arbitrary rectangle. Okay. And go to constraints, select equal, select this vertical and this horizontal, both become sweeper. And then go to dimension and create this dimension as 50. So automatically it will take the other dimension. Then this is with reference to the one end, it is 82.5, and with reference to the other end, I think it is 20. Yes, here it is given. Go to dimension between this and this, you take this dimension as 20. Similarly, from between these two, you take this dimension as 82.5. So once you have this, so this is actually placed. Then go to finish sketch and go to 3D and go to extrude. Select this profile and give the distance as through all and flip it and say OK. So this is the actual part which we have to create. So I'll go for a save, and this is the housing plate or housing. I will just type housing. Okay, this is the first part. Once you do that, so here actually this is having a green color. So I will just go for appearance and create that as green color here, appearance. Go to paint, then go to glossy and take this green color. By holding on the first button of the mouse, you drag that color onto this model and assign that color. Then once you do that, now you will go to save this drawing or this model. So now the model is being updated. So then the next part, what I want, we'll go to take the same parts which have been created for the other model, the key, what I want, the second part. So to do that, again, I will go for remove this and go to part design and make it hybrid. Then we will go for sketch, click on the front plane. Now create a rectangle of 5 by 6. So go to sketch, take some arbitrary rectangle here, go to dimension. Here, first you take a dimension between these two. Sorry, go to dimension between this and this. You give it as 2.5 and you give this dimension as 5. Similarly, between this and this, you give the dimension as 3. And from here, this dimension as 6. Once you do that, you just go to finish sketch and go to extrude. Click on this and give the dimension as 25 mm. Give 25 and say new body and say OK. Again, go to appearance. Now you take blue color here and drag it and place it and say close. So now I'm going to save this part. Go for key, send. Now, the next part is I want to come to this cam profile. So to do that, here I will take the same dimensions and except that the profile will going to be changed. So to do that, so first I will go for design, make it hybrid and say convert. I'll go for a sketch, click on the front plane. Now I want to have the displacement diagram. So to do that, I will go for line, click on construction and take some arbitrary point and draw a vertical line and go to dimension and give the dimension as 50 because there is a lift of 50 mm. Okay. And then I want it on the horizontal direction. So I will just go to select and you drag it and place it wherever you want. I will go for a line and you place this at any distance and go to dimension and give the dimension as 360. Then I will go for line, select one vertical line. Similarly, you create at some distance one, then you create one more here, then you create one more here. Okay, so we want 4. So then I will go for equal. This is for the outstroke, then this is for the dwell, and this is for the return stroke, and this is for the dwell period. So then I will go for line, select this. So what I have done is I have taken 1 mm for 1 degree. That is the scale what I have considered. So once you do that, now we will apply the dimension between these two. Since it is 60 degree, so it will be 60 mm. Then from here to here it is distance is 45. Then again from here to here it is 90. Then the rest period will be the 12 period. Okay. Now I will select this dimension and I will keep it out. Now I will go for constraints. I will remove the constraints and go to circle, select the midpoint of this and draw this endpoint. Then go to trim between these two. Now you go for create and go to circular pattern, select this and take the center point of this as this point and give it is partial, it is 180 degree and give the total as 7. So 1, 2, 3, 4, 5 and 6. Say OK. And then go for trim, select this on this side and remove this. Then I will go for array, create rectangular pattern, select this, the quantity is 6, then I want the distance to be 10, okay, then it is spacing and give the distance as 10. 1, 2, 3, 4, 5 and 6 and the quantity in this y direction is 1 and say OK. So this is the first part. Similarly, I will go for create, go to rectangular pattern, select this as the first point. Then I want the total quantity is 6 and the distance between these two is 15. Okay. And then the quantity in the y direction is 1 and say OK. So 1, 2, 3, 4, 5 and 6. So once you get this, now we will go for line, select endpoint and draw perpendicular to this. Okay, sorry. And I will trim this portion. Let it be like this. Okay. Then again, okay. Go to line, select end, go to line, select endpoint and draw perpendicular to this. Again, go to line, select endpoint, draw perpendicular to this. Okay. Again, you go for line, take perpendicular to this line. Again, press escape. Again, go for line, select endpoint to this perpendicular to this and press escape. Once you have these points, now I want to join all these points by means of a spline. You just go to fit point spline, select on this, remove it as the construction line, take endpoint of this to intersection to this intersection to this intersection to this intersection to this intersection and to this endpoint end. Similarly, now I want it on this other side. I will again go to fit spline, select this, end of this to 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 end of this, enter, click outside. So now we have the points. Again, you go for trim, select on this side, trim all these entities here. Okay. Then you go for select, remove this. Remove this. Similarly, delete this, delete this. Okay. And everything is removed here. Similarly, on the other side, you go to trim, select this line, this on this side and on this side, this side. The rest is the 12 period. So we need not have to worry about those points. Now, the next thing is I want to draw a circle. Now I want to create this model. Now, either to what we have done is we have created only the displacement diagram. Now I want to go for this cam. Here first I want to have the circle of radius diameter 50. So first I will go for circle and remove it as the construction. It's not there. I'll go for circle. I will take some arbitrary point. Then go to diameter is 100. Okay. Once you do that. Okay. Now the next thing is I want to create a circle of diameter 40. Again, go for circle. Select some arbitrary point. Go to dimension. Give the diameter as 40. Then you come down to concentric. Select on this with reference to this one. Then again I go for circle and go for dimension. Diameter is 25. Then go to concentric. Select on this with reference to this. Now we have all the 4 points. Okay. Now I will try to move these dimensions so that you will be having a better clarity for drawing to create your model. Okay. Once you do that, now I want to create at the center, that is the innermost circle. I want to have a keyway which is at 16 mm and you have a width of 5 and which is exactly at the center of this one. So it will go to be 2.5 on one side and 2.5 on the other side. Now I will go for rectangle, select some arbitrary point and then draw this rectangle. Now you go for dimension, select this and give the dimension as 5. And similarly, take this endpoint to this endpoint, give the dimension as 2.5. Okay. Then from here to this center, you give the dimension as 16. Correct? Yes. So once you have this, now I will going to trim this portion and this portion. Now we have the outer one which has been completed. Now what actually he says in the problem, he says that the follower is offset by 10 mm to the right of the cam center. So what does it mean? This is the cam center to the right. So that means I will go draw a circle by the construction circle. I will draw a circle of some dimension and give the radius. So the diameter is 20. So I'll go for concentric, select on this to this. Okay. You have the center point. Now from here I will draw a line. Go for line, again go to the construction and draw one line of any length. And now you go for trim, select this and trim it. So this is tangential to this circle. Then I will draw a line from the center of this to the end of this. So this is the actual position of your follower with reference to the center. And the follower center point will be this, and that is which is at a distance of 10 mm from this one. If you go for dimension and if you try to click on this and you take to click on this, the dimension is 10 mm. So that is how you will be able to evaluate. Once you do that, I will draw a line from center of any length of this angle. Similarly, I will go for a line, select from center, and I will draw one more line. Similarly, I will go for a line, select from this, enter, and draw one more line of any length. So now I need to go for the angles. So I will go for dimension between these two. And what is that? It should be 60 degrees in the beginning. Then between these two, it will be 45 degree. Yes. Then between these two, it will be 90 degree. Yes. The rest will going to be the 12. So that means from here to here it is 165. Yes, it is there. Now I will go for trim this, go for trim, select this one and then this one and this one. So we have made all the things which has been, whatever it has been required, it has been done. If I want to have a better clarity, I will try to move it out so that you can be, select this and I will try to take it out. Similarly, I will take this and keep it here, and this dimension is 16, and I will take this dimension to be 25 and this dimension to be 40, and this is the all the other dimensions. Okay, and from this side it is also like this. So this is how you will be able to create the model. Now once you do that, now since I have divided the displacement diagram into 6 equal points in outstroke, then return stroke. So the same thing I want to do it here. Since it is becoming clumsy, so I will remove the dimensions. I will disable this. Now I will go for dividing between these two by by 10 degrees each. Now to do that, I will go for create, go to circular pattern, select this and take the center point as this. Then it will give you the partial, the angle is 60 degrees and this will be 7. So 1, 2, 3, 4, 5 and 6. So here it should be minus 60, give minus 60. So we have the points here and say OK. Similarly, again I will go for create, go to circular pattern, select this one and then take the center point as this, and here I want partial, the angle is minus 90 and again it becomes 7 parts. So 1, 2, 3, 4, 5, 6. So you will have take this one. So once you do that, now since it is offset by 10 mm and it is tangential to this circle, so all the points will be tangential to this circle now. I will go for line. Again, you will go for end of this to this point. Okay. Then I will go for constraint, go to tangent, select this line with reference to this circle. When the tangent is over, again I will go for line, select this end point onto this point. Then go to tangent, select this line with reference to this circle. Similarly, go to line, select end point onto this point. Then again go to tangent, select this line with reference to this circle. Again I will go for line, select this end point onto this. Go to constraint, go to tangent, select this line with reference to this circle. Similarly, go to line, select this end point to this line. Okay. Again, you go for constraint, tangent, this line, Again, go to constraint, tangent, this line with reference to this circle. Similarly, on this side, again go to line, select this end point onto this line. Similarly, cancel, go to constraint, tangent, select this line with reference to this circle. So this is the one side. Similarly, on the other side also, I want to do that. Again, go to line, select this end onto this, okay. Then go to constraint, tangent, select this line with reference to this circle, tangent. Similarly, I want to go for line, select this endpoint onto this line. Similarly, go to constraint, tangent, select this line with reference to this circle. Then similarly, I will go for line, select this endpoint onto this line and go to constraint, tangent, select this line with reference to this circle. Similarly, go to line, take endpoint onto this circle, constraint, tangent, this with reference to this, tangent. Okay, I will go for constraint, tangent, select this line with reference to this circle. Okay, now again I will come down to line, select this endpoint onto this circle, go to constraint, tangent, select this line with reference to this circle. Similarly, I will go for line, select this endpoint to this line, circle, and go to constraint, tangent, select this line with reference to this circle. Then again, you have a line, select this endpoint, okay, onto this circle, constraint, tangent, select this line with reference to this circle. So now we have all these points. Now the next thing is, whatever it is there on the displacement diagram, that I want to come down to this. So to do that, I will go for a fit option. Okay. Now I will go to modify, click on move, select this entire drawing, that is the sketch. So here I have considered all these points. Then by holding this button, you drag this and bring it very near to this. Okay. So that it becomes easy for you to snap the elements or the entities. Okay. Now I will go for line, select some arbitrary point, and I will try to draw one inclined line of any length. Go to constraint, go to collinear between this and this line. Now we will go for dimension, select this we'll go for dimension, then go to measure and come down to this point, select this line and enter it. So automatically that dimension has been obtained. So what I have done is, I have made this equals from this base circle to this distance. Again, I will go for a line, select this, and I will draw one inclined line. Then go to constraint, take collinear, select this line with reference to this, and go to dimension and come down to this three dot, click on measure, select this line now and press enter key. So you will get that dimension has been transferred here. Again, go for line, select some arbitrary point, that is from this endpoint on the circumference, and go to constraint, go to collinear, select this line with reference to this and go for dimension, select on this, click on this three double dot, measure with reference to this line and give this dimension 25. Similarly, I will go for line, select this endpoint and go to constraint, collinear, select this line with reference to this, then go to this dimension, go to measure, select on this line 37.5. Okay, again go for line, select on this and place it in a dimension, go to collinear, select this line with reference to this and go to dimension, click on measure, select this line now, and what is 46.65, enter. Again you go to line, select this endpoint and drag this and go to constraint, collinear, select this line with reference to this line. But to take the tangential now, not this one, that is the line joined from the origin, go to dimension, select between this and go to measure, select this line. So what is that angle? 50 drawn. Similarly, you go to this point, go to line, select from this point, you take it any angle, go to constraint, collinear, select this line and this inclined line. Don't take this to the line drawn to the origin. To take with reference to this tangential line with to the circle of 10 mm offset. Then go to dimension, select this line and you make it 50 because there is also 50 mm. Okay. The next point is I will draw a line from end point, then go to constraint, tangent, select this line with reference to this line, go to constraint, tangent, select this line, go to constraint, go to constraint, collinear, select this line with reference to this and then go to dimension, select this line and go to measure, select this line now. Okay, enter. Now I will go for line, select this endpoint and drag this portion, go to constraint, click on collinear, select this line with reference to this tangential line and go to dimension, click on measure. Okay, select this line now, enter. Yes, 1 2 3, yes. So this dimension is 37.5. Okay, fine. Similarly, I will go for line, select this endpoint on this side, go to constraint, collinear, select this line, tangential line and go to dimension, or written now, it's constraint now. So here I will go to select and I will delete this and go to line, select this line and drag this point, any line and go to constraint, collinear, this line with reference to this and go to dimension, select it here and go to measure. What is this dimension now? This dimension is for this. Okay, select this and give the dimension as 25. Okay, okay, enter. Now similarly I want to go for a line, take end point and go to constraint collinear, select this with reference to this and go to dimension, go to dimension. It's already constrained. Yes. No. Go to measure. Select this next line, which is this one. Okay. Yes. Click on this. Give 12.5. Similarly, I want to go for line. Select this endpoint. Sorry. Go to line. Select this endpoint and then give collinear. Go to constraint collinear, select this line with reference to this line, go to dimension, select this and go to measure this here, take this point, yes, select this line and press enter key. Now we have all these points have been constructed. Now here I will go for fit point spline, remove this construction and go to endpoint, to this endpoint, to this and to this, to this, to this and to, sorry, and to this endpoint. Press enter key. And here again, I will go for arc, sorry, go to create, go to arc, take, go to create, go to arc, take center point arc, select this center point and take this endpoint with reference to this endpoint. Similarly, again, you go to fit point spline, take endpoint of this to endpoint of this to this to endpoint of this to endpoint of this to the endpoint of this and press enter key and take it out. So this is how you will be able to create the spline. Now I want to go for trim, select this outer one and here also I want to remove this portion and then I will go for select this remaining portion and I will delete this. So this is the actual profile of your cam having 10 mm offset towards the right side of the cam center. Once you do that, click on finish sketch. Now we'll go for 3 dimension. Go to 3 dimension and now we will go for extrude. Select this entire profile and give symmetric and take this on either side. Total distance is 15 mm. Okay, and click on new body and say okay. Once you do that, we have the outer profile. Then I will go for sketch, enable the sketch. Now we will go for the second portion, which is this portion. We are talking about 15 is over. Now I want to take 25 here. Then you just click on this, go to extrude, select this new profile and again go to symmetric and give the distance as 25 on either side. Total distance is 25 and you want to become join. So now I will disable the sketch. So this is how we will be able to create the actual profile of our clamp plate or the cam. So now I want to save this by giving the yellow color for this. So I will go for appearance, take the yellow color and say okay, click on close. Now we will go for fit. So now I want to save this and take it as cam plate. Now, the next part is the follower. This is the one I want to create. So to create the follower, I'll come down to this, close, go to part design, hybrid and convert. And now we go for sketch, click on this sketch. Now I want to create a line from here. I will draw some inclined line and then I will take a vertical line. Similarly on this side and from this side, yes, and to this line, okay. Then I have the total height is 160. Go to dimension between this and this. Give the distance as 160. Then I want this dimension between this and this, which is 7.5. Okay. Then give the total distance is 15. Okay. Now I want to give this line. Go for line, select this construction line and draw one vertical line of any length. And I go for dimension between these two. It is 45 degree on this side. Similarly, on this side also, we want 45 degree. So all the dimensions have been achieved. Okay, constraint, go to finish sketch and go to 3D and go to extrude and give, if you want, you can give equal thickness or you can take it from the one end also. That is not the criteria. So I will go for symmetric distance, okay, and give the distance as 15 mm. So total distance is 15 and say okay. So now we have this as the red color and go for appearance and take this as red and you assign this color and say close. Now we will go for save, type follower. Okay, this is the fourth one. Then I want to create a, once you do that, now we'll go for a shaft. So to do that, go for shaft here. We will create this shaft now. Then you go to part design, go to hybrid, convert. Then I will go for sketch, click on this front plane and go for a circle. Go to diameter, give the diameter as 25 and then you go for coincident, this with reference to this. Once you do that, then I will go for finish sketch, click on extrude, give the dimension as 40. Then I will go for this slot. So to do that, I will go for sketch, click on front plane. Now I want to create a rectangle of any length, of any dimension. Okay. Or I will take the rectangle from here outside of any dimension. Then it is 5 and 2.5 and this is 10. So I'll go for dimension from here to here. It should be 10. Then you take the dimension from here to here. It has 2.5. Then again this dimension to be 5. Okay. So we have the entire profile has been constructed. I'll go for finish sketch and go to 3 dimension and go to extrude. Select this profile and give the distance as minus 25. Correct? Give the distance as minus 25. It is going in a direction opposite to the direction of the arrowhead. Then click on OK. I will go for appearance. Then I will go for paint, glossy white and say close it. Now we will go for saving this file. Click on this and make it shaft. So we have created all the parts. Once we modeled all the parts, now the question is to make the assembly. So to do that, I will go for the hybrid. Now first part I will going to take is the housing. Take it, the housing is the first part. So that let it be on the origin. You just click on OK. So this is grounded. Automatically the first part will going to be the grounded. Then you just bring the shaft here. Then you take it out. Click on OK. Then go to 3 dimension, that is rotate, 3D rotate. Now I will go for OK. Go to joint, select on this with reference to this. So since the motion is here, it is rigid. So I want to revolute this. You just click on revolute. So this is how it will start rotating, revolution. Then I will click on OK. Then go to 3 dimension. So this is the actual position of your model. So now if I just click on this and if you go for motion and say preview, so now you can see it is rotating about the y-axis with reference to the housing. It is been rotating. Okay. Then click on OK. Now the next part is I want to have the cam plate. You drag this cam plate here and place it on the center. Now I will try to move it out and say OK. So now this joint is on this side with reference to this. Now it is rotating with reference to this. So the shaft is also rotating and the cam plate is also rotating. That should not happen because the cam should be fixed to the shaft. Only shaft can rotate with reference to the housing. So I will go for motion and click on rigid here. So this part will going to become the rigid part. Now if I just go to relationship, go to joints, if I revolute this, see what happens. Along with the shaft, this is also rotating. That is possible only because it is the cam plate is fixed directly to the shaft. So that is the reason. Then the next point is I want to have a keyway and I want to place the key here. So I need to take the key out and say OK. Now I want that key to be placed in the keyway slot. So I'll go for joint. Again, I will take the snap of this point with reference to this point here. Okay. I want to be placed onto this because I have not given any clearance here. So this is the point. I will go for the flip. So it will go inside. Since the motion is rigid, I will accept it. So here you can see the motion is rigid and say OK. Now, if I go for revolute and if I rotate, see what happens. Along with the key and the shaft and the cam plate, all the three are rotating with reference to the housing. So this should happen actually. So if I go for 3 dimension and if you see there is a gap here. So this is the one what actually it is required. So if I just go to relationship and if I remove it and you can see how this has been rotating with reference to the axis on the housing, the center pole of the housing. So the next point is we have the last one, which is the follower. I will just drag this and place it here on the center. So once you do that, you will have a copy of this and you take this outside and say, OK. Now I will go for joint, take the cursor onto the top surface of taking onto the top point of this with reference to this point here. Okay. So now it has been placed here. And this, the motion what I want is not the rigid, instead it should slide. So this is what should happen. And when you take it to the center, this will not exactly at the center because you have an offset of 10 mm with reference to the center of the axis. So that is how it will be considering here. Okay. So this is exactly at the center point of this. Okay. Now the position should be from Z offset, it should be 50 or sorry. Okay. I will just go to motion and here it should rest at a distance of 50 from exactly at this point, but there is a gap here, so that gap I need to reduce it. I will take around 49. That is basically because this is not exactly the center. At the center point of that, it will be 50 mm lifter. But when it comes to the 10 mm offset, there will be a decrease in length of the height. So obviously that will be the point what we are talking about since it is offset. So I will say click on OK. Now we have at this particular point. Now I'll go for 3 dimension. So now we have all these things have been assembled. Now, if I just rotate this, you can see that a portion is being lifted by the slide follower, but and here this is the one and here this will going to slide. So both are independent. But what I want, when I rotate this cam plate or the cam profile, the follower should go up and down. So that is the requirement. I will just go to revert position. Now I will go for assemble, click on enable contact sets. So you will going to get the generate contact sets. I will right click on contact set and create new contact set. I will take the template and I will select this position and say OK. That template and the follower. You just click on OK. So automatically that point will go to the position where you have the 49 mm from the center, but it is not exactly the 49, 50, because from the center to the base circle, it will be 50. That is the lift. But since it is at certain angle, at certain distance from the diameter of the circle by 10 mm offset, so obviously that length will going to become less. So that is the situation. Now once you do that, now we go for revolute and click on element joint relationship. Now as you see that the motion is taking place in upper direction, then dwell, outward stroke, outward, dwell, inward, outward, dwell, inward, dwell. So this is how your the option will going to work. So now the next question is, how much is the lift which is considering that I need to do it? So this is the one part of the animation part. So the lifting, how it will going to take, that I need to calculate. So for that, we will consider, I will go to the right view. So I will create one sketch here. I will take it onto this sketch or I will take directly onto this sketch. Okay. So once you do that, now I will go for a line, select some line from here. Okay. Or I will go for project. Okay. Click on OK. Just for the reference, I'm trying to do this. Take the line, end of this. Again, I will draw a line from here of some distance. I'll go for dimension between these two, which is 50 mm. Okay. Again, I will consider one more line of which is of 50 mm. Go to dimension between this line and this line. Go for 50. Okay. So now we have this. So again, I will just press escape and go to revolute and go to animate joint relationships. Now the moment when you go for this, so this is the lift what we have for the 50 mm from here to here. This is how we will be able to demonstrate that exactly how the follower will go to lift by 50 mm. the dimension from here to here it is 50. But actually it will not going to be, it is total distance is 50, because if you observe here, there is a gap inside. So that gap is only because of that 1 mm what we are talking about. So that the same for the reference only, I'm just considering this distance is 50 mm. So this is how you will be able to, now you can see here, the first point is 49 plus this becomes 99. 49 to 99 is the point. Okay. So this is how I will be able to demonstrate that whenever you have a cam profile which is generated having a displacement of 50 mm from the outward stroke, dwell, in return stroke, and the dwell period. So when I come back to this 3 dimension and come to the front view, you will be able to see that exactly how this has happening. So outward stroke, dwell, inward stroke, dwell, outward stroke, dwell, return stroke, dwell. So this is how you will be able to show the demonstrate how the cam profile with a follower knife edge having a 50 mm lift, and the follower is offset by 10 mm to the right of the cam center. This is how it will be animated or showing the joint relationship. Thank you.